An astronaut orbits 254 miles above your head. A passenger jet flies at 35,000 feet. Somewhere between those two altitudes, the air ends and space begins. The question is, exactly where? Most people give the same answer, 62 miles, the Kármán line. But it isn't settled. NASA doesn't use that number. The U.S. Air Force doesn't use that number. The man the line is named after never actually published it. The real border between Earth and space is one of the strangest geography questions in science. The first thing to understand is that there is no edge. The air around you doesn't stop at a specific altitude the way the ocean stops at a coastline. It thins gradually, and the thinning never fully completes. You can actually see this happening. The sky is blue because air molecules scatter sunlight, pulling blue wavelengths out of the beam and spreading them across your field of view. At 62 miles up, there is so little air left that the sky stops being blue. It turns black, and you can see stars in broad daylight. If Earth were an apple, the breathable layer would be thinner than the skin. At sea level, 1 cubic meter of air contains about 25 quintillion molecules. At the top of Everest, a third of that. At the altitude where passenger jets cruise, 35,000 feet, less than a quarter. And from there, the density keeps dropping, but it never reaches zero. The International Space Station orbits at about 254 miles above Earth. This is well above any definition of where space begins, and yet there is enough air at that altitude to slow the station down. If NASA did not periodically fire the thrusters to raise its orbit, atmospheric drag would pull the ISS back to Earth within a few months. Not zero air, not quite space. Something in between. At that altitude, there is also ionized gas, bursts of radiation, streams of charged particles from the sun. Scientists call this environment space weather because it behaves in many ways like weather on Earth, with its own storms and its own quiet seasons. The astronauts on the ISS are not in a void. They are inside a dynamic, constantly changing environment that happens to be almost entirely invisible. The outermost layer, the exosphere, extends as far as 6,200 miles above the surface, depending on the definition. If space meant the absence of any atmosphere at all, the boundary would be tens of thousands of miles away. So if the atmosphere never truly ends, where do you draw the border? In the 1950s, a Hungarian-American physicist named Theodor von Kármán tried to answer this question, though not in the way most people assume. He was not trying to define where space began. He was trying to solve a practical engineering problem. At what altitude does an aircraft stop behaving like an aircraft? An airplane stays aloft because its wings generate lift. Climb higher and the air gets thinner, so you need more space to produce the same lift. At a certain altitude, the speed needed to fly equals the speed needed to orbit. Below that line, you're flying. Above it, you're essentially in free fall around the planet. Von Kármán calculated that altitude at roughly 52 miles, not 62 miles, 52. He never published the calculation. A colleague wrote up the idea and named it after him. Then, in the early 1960s, the Fédération Aéronautique Internationale, which keeps world records for spaceflight, rounded his number up to 100 kilometers, 62 miles. Easier to remember. That is where the 62-mile Kármán line comes from. It's not a physical boundary, it is an administrative one, chosen partly for convenience and partly to give record keepers a clean number. The line also matters for a reason that has nothing to do with physics. Below it, the sky above a country is that country's sovereign territory, the reason foreign aircraft need permission to fly over. Above it, international space law takes over, governed by the Outer Space Treaty of 1967, which says no nation can claim ownership of space. Nobody owns the sky at 100 kilometers. Everybody owns it at 99. That is why the exact altitude is still debated in courts and treaties today. Enjoy deep fact-check space stories? Hit subscribe and activate the notification bell. Otherwise, YouTube will not show you the next videos, and you'll miss what we uncover next. If you were a U.S. military pilot in the 1960s and you flew above 50 miles, you received astronaut wings. Not 62 miles, 50. This was not an oversight. The U.S. Air Force picked 50 miles because it matched the altitude of the boundary between the mesosphere and the thermosphere, a real physical transition in the atmosphere. NASA used the FAI's 62-mile figure until 2005, when it switched to 50 miles too, because some military pilots who had flown the X-15 test aircraft in the 1960s had reached altitudes between 50 and 62 miles. Under the FAI standard, they were not astronauts. Under the military standard, they were. The inconsistency was fixed by aligning everyone to 50 miles. There is also a more recent argument for the 50-mile boundary. In 2018, Harvard astrophysicist Jonathan McDowell analyzed the orbits of 43,000 satellites. He found that satellites could survive above 50 miles, looping back toward Earth and climbing again. Below 50 miles, they met a fiery end almost every time. The physics of orbit actually starts at 50 miles. Von Kármán's own original calculation had been 52 miles. McDowell's analysis confirmed something closer to 50. The 62-mile line, meanwhile, had no strong physical justification. It was just a round number in kilometers. And then there is a fourth definition used by NASA Mission Control itself: 76 miles. This is the altitude at which atmospheric drag becomes noticeable enough to matter for spacecraft re-entry calculations. When a returning capsule is coming back from orbit, Mission Control tracks its progress against this line, not 50 miles, not 62, 76, because that is where the math of the fall changes. 4 different numbers, 4 different institutions, 4 different reasons for picking each one. All of them are in use today simultaneously. There is a reason governments have refused to agree on where space begins, and it has nothing to do with physics. Below the Kármán line, the sky above every country belongs to that country. National airspace. Flying a plane through it without permission is a violation of international law. Above the Kármán line, different rules apply. The 1967 Outer Space Treaty declared that space belongs to no nation, cannot be claimed by any country, and must remain open for use and exploration by all. This makes the boundary itself politically explosive. Draw the line too low and countries lose the right to control what flies over their territory. Draw it too high and space activities become subject to sovereign national laws they were never designed for. So governments have mostly refused to draw it at all. The United Nations, after 60 years of committee meetings on the subject, has formally declined to set a boundary. The United States has actively resisted efforts to define one in international treaties. The vagueness is not an oversight, it is a choice. As long as there is no agreed-upon line, no lawyer can argue a satellite violated airspace. No military can be accused of illegally overflying a border from orbit, and no space tourist can be definitively denied astronaut status by a foreign government. So which number is right? 50, 52, 62, or something higher? The answer is more interesting than any of them, because even above all of these lines, you are not fully in space. You are just in a different atmosphere. Above Earth's atmosphere, there is the Sun's atmosphere, a stream of charged particles blowing outward from the star, filling the entire solar system. The region dominated by the solar wind is called the heliosphere. We live inside it. Its outer boundary sits at about 11 billion miles from the Sun. The Voyager 1 probe crossed it in 2012, becoming the first human-made object to enter true interstellar space. By the strictest definition, space actually begins about 11 billion miles above your head, not 62. Where does space begin? For a pilot earning astronaut wings, 50 miles. For an international world record, 62 miles. For NASA Mission Control calculating re-entry, 76 miles. For where Earth's exosphere fades to nothing, 10,000 kilometers up. For true interstellar space, billions of miles. None of these numbers are wrong. They are answers to different versions of the same question. The boundary between Earth and space is not a physical wall. It is a set of thresholds, each one useful for different purposes. The air above your head is connected, without a break, to the air 100 miles up. And above that, the Sun's atmosphere is waiting. We live at the bottom of a gradient that never quite ends. If you want to understand what exists past every single one of those boundaries, past Earth's air, past the Kármán line, past the Sun's atmosphere, past the planets themselves, there is one more question worth asking. What does our solar system actually look like from the outside? Watch What Does Our Solar System Look Like from Outside to find out.